Hello, we're now at the topic of current of electricity. Yay! Okay, we have a battery here. What does a battery do? A battery only has one mission in life. It's to make sure that there's a high electric potential at its positive terminal and a low electric potential at its negative terminal. We have a resistor here. Let's connect it across the battery. So now we have a high electric potential at one end of the resistor and low electric potential at the other end of the resistor. So this potential difference will force a current through the resistor and through the circuit. We're very fond of this analogy here. So the battery is like a water pump that arms the water with GPE, gravitational potential energy. So the resistor is kind of like a water mill where the water converts its GPE into other kinds of energy, hopefully useful work. So the height difference kind of corresponds to the voltages you will measure across the battery and the resistor. But the one that's measured across the battery is called the electromotive force, EMF. But the one measured across the resistor is called the potential difference. Let me elaborate. So this is a battery. A battery must contain some mobile charges. It could be positive, it could be negative. For convenience, let's just assume that this battery contains mobile positive charges. Charges in a battery will always experience a EMF force that tries to pull the charges towards one side of the battery. For a chemical cell, this EMF force will be chemical in nature. It could be other kinds of forces if it's a photoelectric cell or electric generator, but whatever it is, there's always an EMF force that tries to pull charges to one side of the battery. So because of this, you can imagine that there will be accumulation of positive charges on one side and negative charges on the other side of the battery. Once you have this separation of charges, an electric field will develop. And notice the direction of the electric field will be to push the charges in the opposite direction. Once there's enough accumulation of charges, once the electric field is strong enough that the electric force matches the EMF force, then the accumulation of charges ends. And this resulting voltage across the battery is called the EMF. We have a resistor here. Let's connect it to the battery. Once the connection is made, the accumulation of charges will extend to both ends of the resistor. You can think of this entire part here as the positive terminal of the battery. You can think of this entire part here as the negative terminal of the battery. Because of these charges, an electric field will develop across the resistor as well. What do we have in a resistor? Mobile charges. Could be positive, could be negative. For convenience, let's assume that there are positive charges. So if you have positive charges sitting in an electric field that's directed this way, you experience an electric force that's this way. That's how we end up with an electric current in this closed circuit. Actually, I've gone beyond the A-level syllabus, yeah? So for the A-level syllabus, what you need to know is what I'm going to tell you now. If you connect a voltmeter across the terminals of the battery, the voltmeter will measure a voltage, let's say 3 volts. So this is called the EMF of the battery. What does 3 volts mean? 3 volts means 3 joules per coulomb. It means that every coulomb of charge that's ferried across the terminals of the battery is armed with 3 joules of electric potential energy. If you connect a voltmeter across the resistor, you will also measure a voltage, and that voltage is called the potential difference. Let's say it's 3 volts. What does this 3 volts mean? Again, it means 3 joules per coulomb. It means that every coulomb of charge that passes through the resistor loses 3 joules of EPE into other forms of energy. Heat, light, work, whatever. Yep, that's all you need to know for the A-level. And I think it's quite satisfying to notice that in a battery, the EMF force helps the charges to go against the electric field. That's why the charges gain EPE as they get ferried across the terminals of the battery. In the resistor, the charges are just going along with the electric field. After all, it's this electric field that pushes the currents through the resistor. Alright, that's all. Ta-ta!